A 100,000 loan has annual nominal interest rate 8%, convertible quarterly. The loan will be repaid with quarterly payments. First payment is due 3 months from the date of the loan. For the first 5 years, each payment will be 2,500. All payments thereafter will be 5,000 except for a final balloon payment. Calculate the balloon payment. So first of all, since the payments are quarterly, so we need the quarterly effective rate. So 8% is the nominal quarterly rate, which is I superscript 4. So the quarterly effective rate J will be I4 by 4. So 8% by 4, which would be 0.02. So different things are happening in the first 5 years versus thereafter. So in the first 5 years, we figure out how many quarterly payments there will be. So it'll be 5 times 4. So 20 quarterly payments in the first 5 years. And the present value of these 20 payments, let's call it P1. That would be by our basic present value formula for annuity immediate, since payments are happening at end of quarters, so it's annuity immediate. So payment is 2,500, 1 minus 1 plus interest rate, which is 2%, power -20, since there are 20 payments in the first 5 years, over 0.02, and this comes out to be 40878.58. And now, from the remaining payments, the balloon payment will happen among the remaining payments, which start after year 5. And first, we assume that there are n remaining payments, each of 5,000. So we disregard the balloon payment for now. And once we figure out the n, then we will go back and bring the balloon payment in. So since the remaining payments start at quarter 21, so they are happening after 5 years, so they'll start happening at quarter 21. But again, the present value 25.4 equation will give the value of these payments at quarter 20, since 25.4 is an equation of this kind, which is the present value of annuity immediate, which we know always gives the present value 1 period before the first payment. So these next series of payments of 5,000, they start at quarter 21. So this formula will give their present value at quarter 20. And so that would be 5,000, 1 minus 1 plus 0.02 over 0.02 power negative n. And now we bring this to time 0 from time 20. And so we multiply it with 1.02 to the -20. And so, okay, this needs to be 5,000, not 5,500. So the value of the loan should be the sum of these two present values, the first payments in the first 5 years and the remaining payments. So their present values are respectively P1 and P2. So the total value of the loan is 100,000. So 100,000 should be P1 plus P2. And so P1 is 40878.58, and P2 we just figured out is this. And so from this equation, we get n equals 21.86. So as we've done in the previous problems, we'll first subtract this quantity from the 100,000, and then you can multiply by 0.02, divide by 5,000, divide by 1.02 to the -20, and then go from there. So now n, remember, is the number of payments, which has to be an integer. So our calculations are telling us that n is 21.86, which means that after 21 regular payments of 5,000 are made, we need 0.86 of a regular payment in the next period. So therefore, if we want a balloon payment, so that means that instead of making 21 regular payments, we should only make 20 regular payments of 5,000, and then the 21st should be a bigger balloon payment where we should lump everything that's needed to pay off the loan. Let the balloon payment be Y. So now the payments of 5,000 start at time 21 if we count in quarters. And and since we are saying that there should be 20 of them, so if they start at time 21, so they should go from time 21, time 22, 23 up to 40. So these are 20 payments, and that means a balloon payment will happen at time 41. And again, just to specify in quarters. We have the units of time here are quarters. So the loan is a present value of payments 1 through 20, which were the initial payments of 2,500, plus present value of payments 21 through 40, which were the regular 5,000 payments, plus the present value of balloon payment. So 100,000 was the loan. Present value of the first series of payments was 4,878.58. And then the present value of payments 21 to 40, if we use this formula, it would be 5,000. So if we go here, that was the P2. And now we decided that N was 20 here. So it would be 5,000, 1 plus 1 minus 1 plus 0.02 to the negative 20 over 0.02, and then the 1.02 to the negative 20 brings it back from quarter 20 to quarter 0. And then plus the present value of the balloon payment. The balloon payment was Y and was happening at time 41. So you bring it back through a factor of 1.02 power negative 41. And from this equation, Y comes out to be 9237. So again, just to recall how we do this, we subtract this and this whole thing from the 100,000 and then divide both sides by 1.02 to the negative 41, or multiply both sides by 1.02 power 41 in this order. And that gives Y equals 9237. That was choice E.